So I want to talk about the final exam and possibly moving it up a little bit, but I'll wait maybe 10 minutes before I start talking about it because some people might get in late. So we'll talk about it. Let's get back to moment of inertia, or as here it says, product of inertia for the shaded area. So what we've been talking about so far has been I either around axis X or I around axis Y. It's usually opposite. So X is going to be Y2 dA, and about axis Y is going to be X2 dA. Okay. That's usually for shapes that are irregular, or the problems that we have had before, like this one, or something like this, which we haven't done yet, or stuff like this, which is just an arbitrary random area, okay? But for this, when I look at this, I see a rectangle and a circle, and I'm thinking, well, there should be a better way of doing this. So I don't have to integrate over and over for a circle or integrate for a rectangle. And there is a better way of doing this, and that's calculating or using tables or calculating pre-calculated values for these shapes. So before doing that, let me just break it down a little bit. So this is what we know as a composite area, okay? Similar to composite area when we dealt with Centroid, okay? So the composite area so I about axis X, if that's what I'm trying to figure out, looks like a T. Okay, that means summation of, okay, which is, let me call this area 1, let me call this area 2. So it's pretty much summation of area 1 about X, summation plus area 2 about X. Or maybe a better notation would be Ix for area 1 plus Ix for area 2, whichever is more clear to you. That means moment of inertia for area 1 plus moment of inertia area 2. In this case, however, the area is deducted from it, so it should be minus. Okay. What it means is y, x, so I 1 over x minus area 2 it will result in what I'm after. Okay. So I need to find I of this area and deduct area 2 from it. All right. So let's look back on Blackboard. There are some tables that I posted from your book. Geometric properties of areas and centroids. If you look at last page of your e-textbook, or pretty much a lot of other engineering textbook, dynamics, mechanics of materials, machine design, all of those books, you're going to see tables like this. All right. So let's see what it means and how can you use a table like this for area. So let me see. Here we are dealing with a rectangle and a circle. So let me kind of zoom in on those. All right, so it says I about x for a rectangle is 1 over 12 b, which is this length, h cubed. All right. I about y-axis equals 1 over 12 h, h over b cubed. But one thing you got to pay attention is it's about x-axis. Where is x-axis going and where is it passing through? You guys know?
The centroid.
So this C, now you know that this C represents centroid. So this is I about centroid. Okay. Same thing with the circle. It's 1 over 4 pi r to the power of 4. Again, same thing. It's about centroid. Okay. Or both of them. So now I know I have an IX112BH3. Let me go back to my this. So for this, I about centroid is going to be 1 over 12 BH3, which in this case is going to be 1 over 12. B is this length, 4. H is this one, 6, 3. Okay, and it's going to be inch 4. For the circle that I'm looking for, I above centroid is 1 over 4. Was it pi r4? Pi r4. So it's going to be 1 over 4 pi. R is 1 inch. So it's going to be 1 to the power of 4 inch 4. Okay. So do you think, can I just do this minus this one and find my I? Yes or no?
No, because they don't share the same centroid.
Okay. What if they share the same centroid? What if the circle was right here? So the centroid of circle and the rectangle were the same.
Our x-axis doesn't go through the centroid.
Okay, see that's an important. So this one is I about centroid of this, is not I about this x. So this is not the same. Same thing with this one. This I that I just calculated is about this x. Okay, not about the x that I'm looking for. So this is x prime. Okay, so we can say this one is I x prime. For this one is about this one, x double prime. So it's going to be I x double prime. So I have some information, right? This handbook or this table was very helpful. I have something, but it's not quite the thing I want. All right. So this is what we use, and it's known as parallel axis theorem, which I went over it in my video, but if I didn't, or if you didn't watch my video, this is how it works. Ooh. There we go. So if I have an area, any area, and this is the centroid of that area, okay? And this is another arbitrary axis. If I want to find I about x, I can use I about centroid plus C squared A, which C is the amount of shift or the distance between x prime. We usually show this with cy, so I can just add this y here. So this is I about centroid. This is the amount of shift, and this is just the area. Okay, so for if I want to find centroid about y axis, all I have to do is find I about sorry, this needs to be y prime plus c2, this time is called cx. So the shift between the centroid axis and the y axis, cx. So same thing, I about centroid, amount of shift, or the distance, and this is just the area. Okay, so this is known as parallel axis theorem. It has a kind of a big scary name, you know, but in reality you just add the amount of shift of axis to your I. So now with knowing this, you kind of understand why they gave in these tables, they gave the I about centroid of that shape, you know. So because they want to list it in this table only once, they want to give one equation for every rectangle regardless of what axis. Any axis that you want to find it about, all you have to do is just add the amount of shift to this and you have it. Same thing with circle, same thing with this. So usually the regular areas are listed. Remember triangle 1/3? We used this before. 1/3 from the base. Rectangular area is in the center, circle in the center, a half circle, a quarter circle, a circular section, and all of that. All right. So this is the meaning of these tables. Usually these two are very popular to remember. As an engineer, and believe me, you're gonna remember these two by end of this course because you're gonna get to use them a lot. And the other shapes, if you want, you don't have to memorize any of those. You can always refer to these tables or just like Google or find in other standard tables, and they're usually listed. So now, with this information, let's just go back to solving our area that we intended to do. So I had this here. I think I got rid of the shape, the figure. Okay, so this is 6 and this is 4. This had R of 1 and was located at 4 inch. Okay, that's all I care about. And the units are all in inches. Okay, so from a composite area, I can write this. I can write I x minus I x equal this I x. This is for area 1. I honestly don't know which way to put the 1. You can say I1x or I can say IX1. It just means area 1, area 2. Okay, area 1, area 2, and this area. This is from composite area. From parallel axis theorem, I know that I can use the centroid plus the amount of shift. So all I have to say is I x, or let's call it C, about centroid plus the amount of shift, right? The difference between axis and centroid, which is going to be 3. multiplied by area minus the second I is I above centroid plus the amount of shift, which is 4 inches area. Okay. So now all I have to do is just plug the numbers in. This one is 1/12, the base, which is 4, multiplied by 6 to the power of 3. This is I. And the area is 4 by 6. These are all inch 4 minus I of this one above centroid, 1/4 pi 1 to the 4 plus area. What is a area of a circle?
Pi r squared.
Pi r squared. There we go. I know it's very simple, but this is the biggest problems the students have when doing composite area. Forgetting area of a triangle and area of a circle. So this is just a bunch of numbers. Should be able to do it. And that will result in 237 inch to the power of 4 for this area. Questions? We're going to do a couple more on this, both of them, composite area and parallel axis theorem. Okay. All right, so before moving on, let's go back and talk about the final exam. So I put on Blackboard a quiz, so you're going to get some credit for it too, just by answering this question. So the current, let me explain what it is. So I'll just write it down here. So right now, the final exam for statics is Wednesday, May 12th. That's the schedule set by university for all of the classes that meet Monday, Wednesday, Friday at this time. And that's a 2-hour window, 3:30 to 5:30. Okay. That's currently our final exam schedule, which has been set. This is usually set 5 years ahead of time. So, but now we are kind of ahead, right? So Wednesday, Friday, and next Monday, I'm gonna do review for everybody. If you guys agree, and if everybody votes on it, instead of this, so we're not gonna have this, instead of this, final exam is going to be next Wednesday, which is 4th, 5th. 5th, during regular time of the class, 2 to 3 p.m. So no one should have any conflict with it. It's going to be this. So that's what I'm asking you. And then that's it. Our class ends. There's no lecture that Friday. There's no final exam during final exam. So this will give me a little bit of time to get ahead of schedule and grade the exams because I have other classes to grade during final exam, and it gives you time during your final exam. So this is open right now. If you agree, and I've explained the same thing here, if you agree, just please head to Blackboard, click on it, and write a submission. All you have to do is says yes, no. And if you say no, it's nothing against you. If you say yes, it's nothing against you or to your benefit. I don't need explanation, just yes or no. Please head to Blackboard and do it. So
Will the same amount of material be in the test?
Yeah, so that's a good question. Someone says, is it the same amount of material? So obviously the Wednesday finals week is going to be a 2-hour test. So I have to put more questions. It's not going to be harder. Okay. It's just more questions, more extensive. The Wednesday before, if I want to do it, it's going to be similar to one of other tests because I have to reduce it to 30-minute material and then 30-minute to upload and stuff. So it's a 1-hour test versus 2-hour test. Same amount of material, but it's just more questions on the final exam. I have to make it a 2-hour test. So that's the difference. That's a good question.
I don't want to influence anyone, but please say yes.
Well, that's influencing everyone. I mean, it's okay, but
Are some of the assignments going to be moved around then?
no. Okay, that's another thing. Yeah, so the activity 8, which went live, it's still going to be due that Friday, next Friday. Okay, which is just writing a discussion on Blackboard. So again, vote freely. I don't want to put anybody under pressure. For me, it's not a big difference. And if you say yes or no, it doesn't count against you or to your benefit or anything. So vote freely, whatever you want to do. Well, I'll let you know by this Wednesday what I'm gonna do. I gotta look to see what people said and stuff like that, but I'll let you know soon. Okay, did everybody agreed on it? Or did they have a chance to do it? I mean, this is open. And the students who are missing, I'm gonna email them and ask them, but I thought you guys that attend lectures should get some credit too, so. All right, so we're gonna continue. If you've done this, please, if you've done it, thank you. If not, please complete it. It's gonna be open. I'm not gonna close it. All right. Any questions about this problem? Okay, let's do another one that is also a composite area and has all of the. Let's do number 3. So this one says y, look at centroid at x prime, the cross section, area T beam, and then find moment of inertia about the x prime. Okay. Okay. So let's see. Let's take this to the whiteboard. All right. So let's just start with the y bar, location of center. We did a very similar one. I think the numbers maybe were different, or were the numbers the same? Do you guys remember the problem we did? Was the numbers the same? Let's see.
I think they're different.
Yeah, they're different.
Okay, let's see. I can check really quick. That was chapter 9. Oops. Oh yeah, these are different. 241. Yeah, okay. Never mind. But it's similar, right? But the numbers are different. So we can go a little bit faster. But I'm talking about y bar. This this right here. And to do this centroid for a composite area, I can break it up into two different areas, right? Okay, something like this, area 1, area 2. There are other ways to break this up too. Some people might like to break this up by one big area in the middle like this, two little areas on the side. Absolutely nothing wrong with it. Any way that you break up the area, that's acceptable. In this case, you have three areas to deal with, right? You have y tilde 1, area 1, y tilde 2, area 2, y tilde 3, area 3, divided by area 1, 2, 3. In this case that we are doing, it's just simpler for calculation purposes. That's it. Y tilde 1, area 1, plus y tilde 2, area 2, plus area 1 plus area 2. Okay, so let's do this one first. Y tilde is the distance between centroid of this part. Okay, so this is y tilde 1, which is going to be 250 over 2. So it's going to be 125 multiplied by area 1, which is 50 by 250. Okay, this is y tilde. This is area 1. Plus y tilde 2 is this one right here, which is 250 plus half of 50, 275. And then area 2 is just going to be 50 multiplied by 300. Okay, so this is y tilde 2, this is area 2. Total area, 50 by 250 plus 50 by 300. Okay, so this is M2, this is M3. The result of this is going to be 206.8 millimeters. Questions about Y bar? If you have questions, we did one before this, which I explained a lot more. Both the video lecture is available and it's in the practice problem, so make sure to check that one. All right, should we do the second question asked about I about this new axis? I about centroid. Okay. So it's I1 about this centroid plus I2 about this centroid. That's the composite area. Okay. This new axis that I found, which is 206. Based on my calculation, 206. This is where we want the I. So for area 1, I can say I about centroid plus amount of shift, right? And multiply by area 1. For area 2, I can say the same thing. I about centroid of that area plus, let's call it C1. C2 squared A2. The amount of shift. Okay, this is just the equation for it. Is everyone following? So let's write I about centroid. Yes, is there a question?
When you say the I about the centroid, is it the centroid of the total area or the centroid of just the one part we're looking at?
Centroid of area 1. And this is centroid of area 2. So this is what I mean. This is area 2, right? So the I above centroid of area 2 is going to be above centroid is going to be 1 over 12 something multiplied by something to the power of 3. So which one has the power of 3? Which one doesn't have the power of 3? For this area only. Trying to find I about the centroid of this. This is what we go to the table and look at, right? Table says 1 over 12 BH3. So what is B? What is H?
B is 300 and H is 50.
So B is 300, H is 50. All right. So it's usually about whichever axis that we are trying to find. This first one is what is parallel to that axis. Okay, let's quickly look here. So when we want to do, let me just see, there we go. So when we say about X, this one is parallel to X. See that? So B is the one parallel to X. And this one is perpendicular to X, is the H one. Same thing here. About Y-axis, 1 over 12. H is the one that parallel to Y. See that? H parallel to Y. And B is the one perpendicular to Y. So it all depends on which one is parallel, which one is perpendicular. So now when we look back at our problem here, 300 is the one that is parallel to the centroid that we are trying to find. We want to find it about this centroid. Okay. So since we're at it, let's do area 2. What about area 2? I about centroid of A2. It's going to be 1 over 12 something to the power of 3. Which one is B? Which one is H in this case? Which one is parallel to the axis we're looking for?
The base.
Yes, so the base, which one should I put here in the first parentheses? How much is the
50.
base? 50. And then this side, which is 250, you're going to be cubed. All right. So let me put this here. So this is going to be area 1. Which one is area 1? 1 over 12, 50, 250 to the power of 3. This one is going to be 1 over 12, 350 to the power of 3. All right. All I have to do is find the amount of shift between the centroid of each area and this axis that I'm after, which is going to be for area 1 is going to be centroid of area 1 which is located at 250, so it's 125. Okay. So how much is the distance then? What is C1? C1?
125 squared.
So not 125. C1 is the amount of shift. X prime is this axis located at 206. The axis that I'm trying to find is 125. So what is this amount of shift? This is the amount of shift C1.
81.
So it's going to be 206 minus 125. This is my C. And of course the area. Second one, centroid of this is located at 250 plus half of 50, so 275. So this one is going to be 275 minus 206. This is my distance here. Multiple by area 2.
Does it matter if that shift is up or down?
No. No, because you're shifting it up or down. Okay. Okay. Questions? Any questions about these two? I have another good one that we can do. Any questions? All right, so let's look at another one here. Let's look at this problem. Find y bar and I y, up sub y. Okay. All right, so let's do the y bar. You remember the equation for y bar? If you want to do the integration. Y bar.
Integral of
y to
Okay, integral of y tilde dA over integral of dA. So, and we said we will take a little element of area okay, this is going to be dx and this is going to be y. Okay, so my dA is going to be y dx. It's going to be 1 over x dx. Okay, that's my dA. What about y tilde? What is y tilde here? First, what is y tilde in words? Guys, remember? What is y tilde?
that's the distance between the centroid of dA to the x-axis.
Distance between centroid, exactly, of dA and x-axis. Which is, centroid of dA is going to be kind of in the center, right? So what is this then? Isn't this y over 2? So my y bar is going to be y over 2 dA, which is 1 over x dx over integral of 1 over x dx. Okay. I gotta get rid of this y because my variable is dx. I can't have y over 2. Y over 2 is 1 over 2x. So it's going to be 1 over 2 x 1x dx over 1x over dx. So what are the bounds of integral here? What should I put as bounds of integral?
1/2 to 1.
1/2 to 1 because this is dx, so these two needs to be x, and it moves from 0.1 to 1, 0.1 to 1. Okay, I don't have the final number for it. Well, I think I do. 1.6, 1.67 inches. So it's kind of right here. 1.7. So this is the y bar for this area. Questions? Should we do ix? Did it ask for ix or iy? Doesn't matter. Let's do iy. I about y. Remember the equation, the integral is opposite, so this should be x2 dA. When I have I about y axis, which way my element should be parallel to? Which axis? Is it x-axis or y-axis? So my question is, should my element be this way for I, or should it be this way, parallel to x or parallel to y?
Parallel to y.
Parallel to y. It doesn't have to, okay? One thing you gotta know, and this is a little bit more advanced for people who pay attention to this is an integral over an area. So your element shouldn't be, I shouldn't tell you it should be parallel to x or parallel to y. But if you take it parallel to y, okay, it's gonna help you. Oops. Well, whoa, what did I do? Oh, clicked on ruler. There we go. Sorry. There. If you take it parallel to y, your life is going to be much easier. Okay, we already have dA, dx, y, so this is our dA. We already have that. So it's going to be x2, 1 over x dx. The bounds of integral are still 0.5 to 1 inch, and that's it. Okay, so the result of this integral is going to be 3/8. Okay, or 375 inch 4. Okay, now I have a little bit of time, so let's do just an extra practice. Let's do ix. In this case, you have to take the element, well, again, sorry, not you don't have to, it's recommended to take the element parallel to x-axis. Okay, so the integral is going to be y2 dA. I already have my dA. I might need to do a substitute here. Let me go up here. We don't need this anymore. Okay, so let's do dA. dA is going to be what? What is my dA? It's a good question for you guys. This is dy. Okay. What about this length? What is this length? This is a very good question for you guys. What is dA? Kind of clarify. Oops. I'm looking at this graph, oops, in the corner. I have an element parallel to x-axis. What is my dA?
In the chat, someone said x minus 0.5.
X minus 0.5. Not quite. Some people say 0.5, or is that from before? 0.5, 0.5 what? Oh, someone just said 0.5, yeah. So this is 0.5, okay? All the way up to here, but remember, integral means y is gonna go from 0 to 2 inches. So from 0 to 1, this is y from 0 to 1. My dA is 0.5 dy. Do you guys agree? Right here. X is, the length is constant, is 0.5. From y from 1 to 2 inches, my dA is changing. It's going to be y minus 0.5. Or sorry, x minus 0.5. You're correct. Is everyone clear on this? So I have two areas here. One of them is just a rectangle, 0.5 dy. The second half, the area is like this. So this length is dy. And this length is x minus 0.5. Okay. Well, it's actually not x minus 0.5, is 1. So this one, because it only goes up to 1. So that one is going to be 1 over y minus 0.5. All right. So here's the thing. I'll let you know quickly so you can think about it, but I'm going to explain it next time. I'm going to pick up from here next time. So we got to do two integrals. One for this part and one from what is on top of it. Okay. But I'll pick up from here, from finding dA on Wednesday. I'm going to go over it and explain it. But if you guys want to go ahead and practice it, this is what we're going to be working on. Okay. All right. The last thing I want to mention is the last activity is posted. Okay, it's just a discussion. So I'll let you read through it, but pretty much I give you 18 topics and I'm asking you guys to think about which one do you think is the most challenging engineering for you guys as new engineers and young engineers to face in the next decade or so. Everything is explained on there, but you got to head to discussion board and just post your answer on there. Or you can comment on other people's too, but usually people just pick one of these topics, hit reply and explain it. All right, but it's just there. I'll explain it again on Wednesday. Make sure everyone understands it. If you haven't voted for yes or no for final exam to be moved up, please read this quiz 10 under assignments and please vote either yes or no. Okay. All right, if there are no questions, you guys are good to go. Otherwise, I'd be happy to answer any questions.
Remember everyone to vote yes.